In this video, we're going to be looking at more of our AP practice questions from Chapter 3. Question number 7 here gives us a function f of x is equal to 4 sine x, and it asks us to find the 8th derivative. Whoa, so that means we've got to find 8 derivatives. Well, I'm going to start out with just writing my function down here, 4 times sine x. So let's find the first derivative. That 4 is just a constant being multiplied by the function, so that's going to stay. And then the derivative of sine is cosine x. All right, let's move on to the second derivative. Again, the 4 is being multiplied, that's just going to stay. And then the derivative of cosine is negative sine. So I'm going to put my negative in front here, and then times sine x. All right, let's do another one. Third derivative, then my negative 4 is going to stay, and the derivative of sine x is cosine x. So now I'm going to do a fourth derivative, and at this point, usually once you get to the fourth derivative, that's when we start putting a little number up there instead of all the prime marks. Let me see if I can get that clearer. There we go. The fourth derivative of x is equal to, I'm multiplying by the negative 4, so that's going to stay. And then the derivative of cosine is negative sine. So multiplying by that negative, that's going to make my negative positive sine x. So now, notice that this derivative that I have here is the same as what I started with. And so if I keep taking derivatives after this point, I'm just going to go right back through this cycle. My first derivative will also be the same as my fifth derivative. The next one will equal the sixth derivative. The next one will be the seventh. And for the eighth derivative, I am right back where we started. And so the answer is B, 4 times sine x. All right, on question number 8, we're asked to find the derivative of sine of x squared over x. And so if I take a minute and think about what rules I need to use here, I can see that I have a quotient. We've got f over g, so I'm going to need to use the quotient rule. But if I look at the function on top, sine of x squared, I see that there's two functions there. There's a sine, and then there's also a quadratic that's inside the sine function. So that's a sign that I need to use my chain rule. And so I'm going to do that first. F is equal to sine of x squared. Let's find f prime. We're going to use chain rule, so I'm going to do the chart. And my outside function is the sine. I have sine of something, and that something is x squared. So now I'm ready to do the derivatives. My f prime is going to be equal to the derivative of sine of something, which would be cosine of something, times the derivative of x squared, which is 2x. And then the x squared goes inside. So typically when we see this written, that 2x would be brought out to the front, 2x times cosine of x squared. So that's my f prime. I'm going to actually write that up here at the top so I can erase the work I just did. 2x cosine x squared. And I'll erase this. So now we're ready to do the derivative. And for this derivative, for the overall derivative, we need to use the quotient rule. And so let's remember the quotient rule. F prime times g minus g prime times f over g squared. Okay, so my derivative is equal to f prime, which we just figured out was 2x times cosine of x squared. So that's my f prime, times g, which is x, minus g prime, the derivative of x, which is just 1, times f, which is sine of x squared. And this is all over x squared. So if I look at my answer choices, I don't match any of the answer choices yet, so let's do a little simplifying. In my first term here, I've got 2x and an x. I can multiply those together and get 2x squared times cosine of x squared minus sine of x squared all over x squared. And now if I look at my answer choices, I still don't see anything that looks like that. We are kind of close here. Seems like that sine of x squared over x squared, we need that, and we have that, but we don't have the front part of this correct yet. What they have done to get one of these answer choices is they've split up this fraction, taking each term in the numerator and writing it on top of the common denominator. So if I split it up, I get 2x squared times cosine of x squared over x squared minus sine of x squared over x squared. Now, by doing this, in my first fraction over here, this x squareds, those cancel out, and I'm left with 2 times cosine of x squared minus sine of x squared over x squared. And now we have a match. This matches answer D. All right, next question, number 10. Find the slope of the line tangent to the graph of y equals 5 divided by the square root of x squared plus 9 at x equals 4. So whenever we're asked to find the slope of the line tangent, this is just asking us to find the derivative. Notice it doesn't say the equation of the tangent line, it just says the slope of the tangent line. So I just need to find the derivative. So I'm going to rewrite my function down here, and when I do that, I'm going to rewrite how the function looks. I've got a square root in the denominator, and so I know that I can rewrite that square root as a fraction power, but also, since that whole term is in the denominator, I'm going to actually bring it up to the numerator and make that exponent a negative 1/2. Now, I didn't have to work the problem this way. I could have used the quotient rule. We still would have needed to rewrite the square root as a 1/2. But by doing it like this, by rewriting the whole denominator with a negative exponent, now all I have to do is a chain rule. The reason that I can avoid the quotient rule is because my numerator is only a constant. It doesn't have an x up there. If there was an x in the numerator, we would need to do the quotient rule. But since it's just a constant, all we need to do is the chain rule. And so I've got this outside function of 5 times something to the negative 1/2, and then the inside function of x squared plus 9. That's two functions. So I'm going to set up my table, 5 times something to the negative 1/2, and then x squared plus 9. So if I multiply negative 1/2 times 5, I've got negative 5/2 times something, and the negative 1/2 minus 1 would be negative 3/2. And then the derivative of x squared plus 9 would be 2x. And this x squared plus 9, that's what goes inside the parentheses here. Okay, so I have my derivative, and we could rewrite things and simplify. Actually, I think I will. I think I will simplify. So dy dx is equal to, I can multiply the 5/2 times the 2. And if I do that, I'm going to get negative 10 over 2, which really just leaves me with negative 5. It's like those 2's cancel out. So I've got negative 5, and then times x, this x over here. Now, my x squared plus 9 that I have left has a negative exponent on it, and since that exponent is negative, I'm going to rewrite that down in the denominator. Since the exponent is a fraction, I'm going to make this a root, and it's a square root because my denominator is a 2, but my numerator is a 3, so I still need to raise this to the third power. And so that's the rewrite of my derivative. Now we're ready to plug in, what did they give us? X equals 4. So I'm going to evaluate the derivative at 4. And this is some notation that we use to show that we're plugging in a number. Actually, I should have put x equals 4. So I'm going to plug in 4, negative 5 times 4 over the square root of 4 squared plus 9 cubed. So I've got negative 20 in the numerator. And in the denominator, let's see, 4 squared is 16 plus 9 is 25. Square root of 25 cubed. Now at this point, you may be thinking, wow, I have no idea what 25 cubed is. Well, the nice thing about this is that since we have a square root and a cubed, and they're both like exponents, they're both at that level in the order of operations, I can do the square root first. And so this is equal to negative 20 over 5 cubed. And then 5 cubed is 125. And then if I reduce by 5, I end up with negative 4 over 25, answer A. All right, last question here. Following table gives the values of some differentiable functions f and g and their derivatives at x equals 1, 2, and 3. And then they give us this seemingly complicated function down here. H of x is equal to f of g of x plus g of f of x. And we want to know what the value is of the derivative of h at 1. So first thing we need to do is find a derivative. If you look at our function here, f of g of x, that's a composite function. The function g is inside f, and we need to use the chain rule. So for that first part, I have f of something, and that something is g of x. The derivative of f is f prime of something, and then the derivative of g is g prime of x. And then, of course, g of x goes inside here. So that's the start to my h prime. That's the first part. H prime is equal to f prime of g of x times g prime of x. But we got to keep going. Plus then g of f of x. So I have a composite function again, but this time g is on the outside and f is on the inside. The derivative of g of something is g prime of something, and the derivative of f is f prime. Of course, this is going to go in here. So plus g prime of f of x times f prime of x. All right, and we want to find h prime of 1. So let me see, I'm going to run out of room here. F prime of g of 1. Actually, I really am going to run out of room. I'm going to get rid of the charts here. Hold on, I'm going to pause and rewrite. Okay, now I've got it rewritten and I've got some space here. H prime of 1 is going to be equal to f prime of g of 1 times g prime of 1 plus g prime of f of 1 times f prime of 1. And so now let's start filling in numbers from the table. F prime of g of 1, so I need to find g of 1 first. And g of 1 is 2 times g prime of 1, which is negative 4, plus g prime of f of 1, so that's going to be g prime of f of 1, which is 2, times f prime of 1, which is negative 3. And then let's fill in numbers here for f prime of 2. F prime of 2, that's 3 times negative 4, plus g prime of 2, which is 6 times negative 3. So I have negative 12 plus negative 18, which would be negative 30.